Hello and welcome. Today we're diving into how AI and remote sensing are transforming landscape-scale conservation in Australia, and why the real breakthrough isn't the tech itself, but designing monitoring systems around decisions that matter on country. Australia faces a paradox: vast, remote landscapes and threats that move faster than traditional monitoring. For decades, we've been monitoring limited. You can't fix what you can't see. That's changing. With satellites, drones, acoustics, and smart analytics, we can watch country continuously and at multiple scales. The magic is turning pixels and sensor streams into evidence that moves policy, funding, and on-ground action. Here's what most miss. The breakthrough isn't a new satellite or fancier algorithm. It's an outcome-first system that weaves Indigenous knowledge, rigorous field truth, and automated analytics into policy-grade evidence. Get that integration right, and you're not just collecting data. You're running a living observatory that responds to threats in real time. I've taught this approach to hundreds of practitioners. The pattern is consistent. Transformation happens when what you measure is directly connected to how decisions get made by rangers, traditional owners, regional managers, and regulators. If you're using genomics or eDNA, snap those signals into the same framework. See the 2025 Genomic and Health Screening Guide. For field methods models can lean on, use the 2025 Proven Monitoring Methods for Australian Conservation. And for community programs, align with the 2025 Best Practices for Citizen Science, so community effort produces decision-grade insights, not just stories. Just as importantly, any AI system must honor local knowledge and data sovereignty. Respectfully share Indigenous Australian Animal Stories 2025 is essential. Australia's scale is often framed as a limitation. I think it's our edge. We have continental infrastructure like Digital Earth Australia, delivering analysis-ready data back decades. That lets us train robust models across bioregions and validate against long histories of change. DEA Water Observations has mapped surface water since the late 80s. DEA Coastlines tracks shoreline positions with sub-pixel accuracy. The National Carbon Accounting System already uses satellite data nationally. That's proof decision-grade Earth observation at scale is possible. Most guides get this wrong because they start with tools instead of outcomes. Higher resolution doesn't automatically mean higher value. What separates top performers is discipline. Every pixel and prediction is linked to a management trigger, a legal framework like the EPBC Act, and a specific action plan. The best programs do continuous validation, build capability with Indigenous rangers and local communities from day one. And don't try to monitor everything. They pick the 3 to 5 critical questions, keeping decision makers up at night, and answer them with confidence intervals and clear thresholds for action. So what does AI plus remote sensing mean in practice? Remote sensing is your dense, repeated measurement layer. Think Landsat 8 and 9 at 30 meters with a 16-day revisit. Sentinel-2 at 10 meters with roughly 5-day cadence. Sentinel-1, radar for mapping through clouds and sensing structure and moisture. Add airborne LiDAR, hyperspectral, drones for centimeter detail, and fixed sensors, camera traps, acoustic monitors, water stations. AI turns those streams into maps, alerts, forecasts, and confidence intervals. The best systems fuse multiple sources and are honest about uncertainty. The patterns that consistently work: multi-sensor fusion, combine Sentinel-2 optical with Sentinel-1 SAR. Add jetty or airborne LiDAR for canopy height and biomass where relevant. Fusion beats single sensors. Domain-specific features: fractional cover, NDVI, EVI, SAVI. Water indices like MNDWI and NDWI, burn severity metrics like NBR and DNBR, texture, topography, climate anomalies. These engineered features usually outperform raw bands. Task-matched models. UNet or DeepLab for pixel-level maps. YOLO or RetinaNet for drone-based object detection. Gradient boosting for habitat modeling on tabular predictors. Temporal models for change detection that spot trends and anomalies. Continuous feedback loops. Field validation with ranger data, bioacoustics, and eDNA. Active learning to bring in new ground truth. And solid MLOps, versioning, performance monitoring, audit trails, and rollbacks when models drift. A lot of this is possible because Australia invested in cloud-optimized geospatial infrastructure. DEA processes 4 decades of satellite observations into analysis-ready datasets. Atmospheric correction, geometric alignment, quality flags baked in. That democratizes access. You don't need a full remote sensing team to start. You can focus on what to measure, why it matters, and how it triggers action. Here's a simple blueprint that moves the needle. First, name the 3 to 5 decisions that really matter. Examples: when to trigger feral herbivore control after a boom year. Where to focus gamba grass management before next fire season. How to prioritize waterhole protection during drought. When to escalate a reef response based on thermal stress and water quality. For each decision, write the action threshold, the confidence required, the legal or policy context, and who will act. Second, co-design with traditional owners and local managers. Set data governance up front. Agree on how Indigenous knowledge guides model scope, how country is represented, and how sensitive data is protected. Third, build a practical ground truth plan. Periodic ranger transects. Camera trap arrays, acoustic points, and targeted eDNA where it adds unique value. Tie each field method to a specific model assumption you need to validate. Fourth, choose a minimal viable sensor stack. Start with DEA optical plus Sentinel-1 radar and a small drone program for high-precision labels. Add LiDAR or hyperspectral only if the decision requires it. Build features proven for your task, not just trendy ones. If you're tracking wetland dynamics, lean on water indices, elevation, and long-term recurrence from WOFS. If you're mapping post-fire recovery, use burn severity metrics and seasonal composites. Fifth, run pilots that mirror operations, not dashboards for show. Weekly workflows that generate alerts with confidence intervals and a clear playbook. For example, when anomaly scores exceed a threshold in a high-value riparian zone, an alert goes to the ranger team with a map, suggested route, and a short list of field checks to confirm or refute the model's hypothesis. Every alert creates new labels and updates the model. That's the feedback loop. Bake in governance early. Version your data, models, and decisions. Keep audit trails to show regulators or funders how you reached an action. Track performance over time and across bioregions, not just inside your training area. Be explicit about uncertainty. It's better to say, "We are 80% confident this patch is invasive grass at this density," than to publish a map with implied certainty. Invest in people. The most successful programs don't outsource all key steps. They build capacity in ranger teams, community scientists, and regional staff, so the system survives turnover and funding cycles. Respect time on country. Data collection follows cultural priorities and local calendars, not the other way around. Leverage Australia's continental context. Train models across climate zones and test out of region. Use long histories in DEA to set seasonal baselines and avoid false alarms after rain or fire. When you need national consistency, say EPBC Act reporting, use analysis-ready datasets and documented, reproducible methods. Finally, Scale what works and cut what doesn't. If a sensor adds cost and complexity but doesn't change a decision, drop it. If a model struggles in cloudy regions, bring in radar or change the temporal window. If citizen science yields presence-only data, adjust your modeling approach rather than forcing a presence-absence frame. Here's the mindset shift that ties it all together. Think of your program as a living observatory of country. It listens across satellites, drones, acoustics, and genomics. It is guided by indigenous knowledge. It ties every measurement to a decision and a threshold. It learns each season, and it stays humble about uncertainty. Because handled well, uncertainty leads to smarter, safer action. Australia is uniquely positioned to lead. We have the data infrastructure, the scale, and the community. If we build systems that are outcome first, co-designed, validated on the ground, and powered by multi-sensor AI, we won't just see more. We'll act faster, with more confidence, and with deeper respect for country and the people who care for it. Thanks for listening, and here's to monitoring systems that help protect species, water, and cultural values at the scale Australia demands.